Welcome everybody at this first TISGRADE Talk. The goal of this TISGRADE Talk to give a brief overview of the work that we are doing within TISGRADE. There are people present that are involved in the project, but also new people that probably would like to know more. It's our first TISGRADE Talk. So the goal is to inform everybody, and for some it might be not too detailed enough, and for others maybe too much details. So please provide us your feedback after this TISGRADE Talk, because the goal is that we inform everybody who is interested in the project about the work we are doing. And today we are focusing on the pre-deployment validations on different topics, which we will explain later. But first, Barbara will guide you through some practical issues.
Yes,
First of all, the meeting is recorded.
Yes, good morning, everyone. As you can see, the meeting will be recorded today. So if any of your colleagues were not able to make it, they can look at this meeting afterwards. It will be made available on our YouTube channel, and the presentation itself will also be made available on our TISGRADE website. If you have any questions during the meeting, please use the chat or raise your hand. There's going to be about 3 presentations. After each presentation, there's room for about 2 questions. So we'll pick out the question in the chat or give you the chance to explain your question via video. And at the end of the session, there's also an opportunity for a broader discussion. So all the other questions can be answered at the end. This is the agenda for today. So Annette will give an introduction to TISGRADE. There will be an introduction to the pre-deployment validations. And then there's Isaac will present the traffic circulation plans and traffic management measures. Stephen will give a presentation about the static data validation, and Bart will present the dynamic data validation. And after that, there's room for general questions and a discussion. And we will also share a slide with our social media channels if you want to be involved afterwards. We're very curious to see who is with us today, whether you are already involved in TISGRADE or if you're new to TISGRADE, and also to see what organization you work for. So I'm going to share a poll. 1 second. Here it is. Let me know if you can see the poll. Please fill it in.
Do you want me to stop sharing, Barbara? Or I don't see, but maybe because I'm in presenter mode. So then.
Can everybody see the poll?
Yes, it pops up.
Yeah.
On top
Okay.
of the screen.
Yeah. Great.
And can you also see the second question?
Maybe you can help me with the outcomes, because
yeah,
I don't see it. So I'm curious who is there, who's already involved and who's not.
I'm trying to see. Okay, 61% of you are involved as a partner, and 34% are first timer. And most people are working at national public authorities, some at regional authorities, and just a few service providers. That gives us an idea.
Yeah, well, good to have such a variety of attendees to this TISGRADE Talk, because that's exactly what we are doing with. And before we go to the details of the pre-deployment validations, I very briefly will give you an introduction about the project TISGRADE, what it's all about. TISGRADE stands for Traffic Information Services Upgrade Europe, and that's exactly what we are trying to achieve, with the goal that road users in Europe have more accurate information about what's going on the road, so that they can make well-informed decisions. But also we want to reduce the social impact of the navigation advices to road users, And we do this by implementing the revision of the real-time traffic information delegated regulation, as well as the RTTI-related aspects of the ITS directive. Well, how are we working on this? We will involve the whole data value chain. So first, we want to work on increasing the data availability.
Sorry, Annette, your screen isn't being shared right now.
Oh,
See?
Okay. Going back then. Maybe because of the poll.
Yeah, I think so.
I start sharing again. Now it's on, huh?
Yes, yes.
First, we are going to increase the data availability because right now it's very scattered in Europe. We will also work on increasing the data quality, the accessibility on the national access points, but also in public-private collaboration, make the data usable for service providers. And there's a new element, several new elements in the RTI revision, which is, for instance, the creation of a public-private feedback loop on data quality. There's no standard for it yet, so we will also work on that topic and come to a proposal how to come to standard for this. And we do this in public-private collaboration, so that's also a very important goal of the whole TISGRADE project. We organize ourselves along the whole data value chain. So here you see in the green all the activities for public authorities, data collection, developing tooling to digitize certain data sets. The traffic circulation plans and traffic management measures are new. And what's also new in the revision of the RTTI is the extension of the geographical scope. So not only national authorities, but also more regional road authorities will have to start working on this. In the work package 3, we will work on the increasing the data quality. And we thought there is a difference between doing that for the static data than for the dynamic data. In the work package 4, we will work on increasing the findability and accessibility of the data on the national access points. And work package 5 focuses on the feedback loop, the technical one, but also creating a public-private dialogue on things that go wrong, could be easily fixed, and to get to know each other more. So there are new elements in the whole RTTI domain, which are the digitization of traffic circulation plans and traffic management measures. For this, we want to do pre-deployment validations, thinking up front, how could this work? Is this workable for service providers? Do road authorities see their objectives reflected? The same goes for the validation of static and dynamic data quality to increase that. And we do that by using the use cases maximum speed for the static data and roadworks and road and lane closures for the dynamic data. And later in time, we will also do pre-deployment validations on the feedback loop on data quality. We'll do them for a year, and after that we monitor, but the task leads of the different pre-deploy validations will work that out later in this webinar. We do it on different locations so that we can test if the workability, the effectiveness is workable all around Europe, with also different parting points for all the road authorities involved. We focus both on urban areas as well as more regional or more national levels, and we will incorporate all the relevant stakeholders so that we have a working ecosystem, just as it will have to be when we are going to implement it, which is also involved in the TISGRADE project. These are the different locations that are involved in the pre-deployment validations. So you see them all over Europe and different kind of stakeholders that are involved. So hopefully after a year we can come up with good recommendations on how to proceed for the implementation. There was a very brief introduction about the TISGRADE project. I'm not sure whether there are some questions already, or otherwise we move over to the main topic of this webinar, being what we are going to do in the pre-deployment validations. No questions, Barbara?
No questions in the chat, no.
No. Okay. Then I hand over to Isaac for what we are going to do on traffic circulation plans and traffic management measures.
Yes, thank you, Annette. So Isaac Iberman for Movias. We are leading the task on traffic circulation plans. On the next slide, yeah, you can see here, well, one of the main objectives of traffic circulation plans, or TCPs as we call them, within the TISGRADE project is to integrate them into navigation services. And why do we want to do that? Well, because by doing so, we hope that traffic flows will be guided a little bit more according to the goals and objectives of road authorities. Here in the example on this slide, you could see for through traffic going from the north of a city to the south of a city, we would like them to use the green main roads around the city center. However, today, if there is a shortcut through the city center from the north to the south, indicated by red here in this picture, and this route is a little bit shorter in travel time compared to the green one, then some of the navigation apps, they will propose the red route instead of the green one. And by providing clear traffic circulation plans and integrating them in the services of service providers, we hope that in this example, the green route will be proposed instead of the red one. So that's a very simple example just to show the main idea behind what we are trying to do here. On the next slide, we see some definitions. So traffic circulation plans and temporary traffic management measures, what are they? For traffic circulation plans, we have a definition proposed by Polis in the Polis position paper. We also have a definition proposed by NEPCOR. And following these definitions, these traffic circulation plans, they are designed to guide traffic flows in response to permanent or recurring traffic conditions. Whereas the temporary traffic management measures, they are designed in response to traffic conditions that may change over time. And so they are, so the temporary traffic management measures, they are dynamic, and the TCPs, the traffic circulation plans, they are static. We use these definitions in our project as a starting point. What we are trying to do within TISGRADE is to come to an agreement on how a digitized TCP and a digitized TMM may actually look like. And this is not only from the perspective of the road authorities, but also from the perspective of service providers. So we are really aiming here to come to an agreement, a public-private agreement on what a digitized TCP or TMM may actually include. On the next slide, you can see how we look at it today. So this is for a digitized traffic circulation plan. We see it as a three-layer concept where you have this base layer, layer one, functional road classes. So functional road classes, they are the basis of traffic circulation plans. And this layer will always be there. So every traffic circulation plan, it has a functional road class description. The other two layers, they are optional. Layer two, zoning concepts, for example, school zones. You may want to avoid school zones, for example, during certain time frames of the week. And the third layer, business rules, they explain a bit more on how these functional road classes and these zoning concepts could or should be used within navigation services. So they provide a little bit more context. So layers 2 and 3 optional. Layer 1 is the real basis, the functional road classes. And on the next slide, you can see how we think functional road classes, no, the previous one, the previous slide, please. Yeah. So on the left, how these functional road classes, how they are used today by road authorities on the left. You can see that a road authority X, they have a certain classification system with a certain amount of road categories in a certain technical format. But another road authority, they may have a different classification system with a different amount of road categories, a different technical format, and so on. So everybody speaks a different language, you could say. On the right side, we have the service providers who are today also using functional road classes within their services, but also there they are using different classification systems with different amount of road categories, different technical formats, and so on. So everybody speaks a different language. And now the question is, if we want to transfer information from the road authorities on the left to the service providers on the right, we will need to make a conversion from classification system A to classification system B. If we want to integrate information from different road authorities to different service providers, you could see here on this picture that a lot of conversions would have to be made. It's a whole spaghetti of conversions. And of course, this is not scalable at all. And therefore, within TISGRADE, we introduce an intermediary layer, and this can be seen on the next slide. A standardized layer in the middle for digitized traffic circulation plans, including functional road classes. And this is what will be published on the national access points. And by doing this, a road authority only needs to make one conversion from its own classification system into the standardized classification system. And also service providers, they only need to make one conversion from the standardized system into their own system. So this is the most efficient way to transfer information on traffic circulation plans from road authorities to service providers. So this is what we will experiment with in the PDVs in the project. And of course, once this information on functional road classes, for example, is integrated in the services of the service providers, on the next slide, we will be very interested to see how this will, in the end, impact proposed routes that are to travelers in the real world. So that is, in a nutshell, what we will be experimenting with in the next year in our different PDV locations in the project. Then I give the word to Martijn on temporary traffic management measures.
Yes, hello, welcome. Martijn Kievit, NDW, and work at task lead of 2.4, temporary traffic management measures. Also there, we're jointly cooperating between task point 2.3 and 2.4 because there's quite some overlap in what we need to develop and how we are thinking. So also here we developed a 3-layer concept, which already is, I think, the second iteration that we have. You see here the layers are slightly different, but the concept is more or less the same. So what we said is there's a basic layer of information regarding traffic management. Because if you look at the definition of temporary traffic management measures, you see it's regarding a trigger and it's regarding the location. But this is all more or less context information for the actual measure that you want to take as a road authority. So that's what we said is there's like some basic layer of information that needs to be available. And that says something about also your traffic management objectives, which roads can be used in case of an incident, which cannot be used, and what existing traffic management means do you have available or not? Do you already have available road message signs available, for example? All that information is assumed to be more or less available. And then building on that, we can say, okay, first of all, as a road authority, you can have like a wish, so to say, that you say, okay, we see there's an incident or multiple incidents on certain sections of the network. And along the lines of what Isaac just explained with the TCP, we say we have a temporary TCP, maybe with additional zones or business rules that actually changes due to these incidents. And we say, okay, now we would like service providers to use the roads in a different way because there's an incident on a main road somewhere. That's still feels a bit free. And then on top of that, if it's really bad, or if you really feel like you really want to have an impact, you can send out requests to the service providers and say, okay, we would like you to avoid, promote, or reroute traffic over different sections of the network. So that's even stronger, more advanced, requires even more agreements, etc. But this is from the conceptual level that we're thinking now how this works. And if we go to the next slide, it's a it's a bit of a big figure, I know, but we'll try to get you through because it's more or less explaining a bit more of where is this temporary traffic management measure, where is it positioned? As I said before, on the left-hand side, you have the disturbance or the incident, and where we're looking at the type of incident, location, and the severity. So this is the first yellow block on the left-hand side, where you see we're looking at roadworks, accidents, congestion, and events, etc. So this is what we need as incident location. This is also part of work package 3, amongst others. So they're looking at this data, how can we improve that, etc. The second yellow block is focusing on the traffic management objectives. How should my network function? And what are the things that I can put in place as a road authority on a traffic functional level? And basically, you can do three things. You can reduce the inflow on a certain section of roads. You can try to improve the outflow, or you can see how you can reroute traffic. That's more or less how the three means that you have as a traffic manager on an objective level. So that you also need to have in order to be able to determine what kind of traffic management measures you want to take. The third yellow block focuses on the existing measures that you already have. So what can you do with the means that you have on the road already? And the last one is already the two layers that I explained. You have the temporary TCP, that's layer 1, and you have the serve request, which is layer 2. So this is how we try to model a bit this temporary traffic management measure to grasp, okay, what do we need to have in place in order to be able to send out information via the NAP to the service providers, and what would we like to happen and in this whole constellation. Well, and then in the PDVs, we also said, we need some more. So if we go to the next slide, we have set up a couple of dimensions, as we called it. So we have layers and we have dimensions. And in the dimensions, we also say, okay, who has to do, more or less has to do what in to get to this pre-deployment, and what do we want to validate? Because that's what these pre-deployment validation locations are about. We still have questions. There's certain ways we can deploy the TMMs and the TCPs, and how can we do that? The first dimension focuses on digitization or digitalization. Slight difference in wording, it means something different. But it really focuses on the road authorities, what part of their work process, what do they need to digitize? And what do they need to publish on the NAP? This really focuses on what this digitization dimension focuses on. The second dimension focuses on, okay, we have digitized this information, and now we would like to see it used, which is more or less together between road authorities and service providers. We're sending the information out, we want to see if you use it, and then get information back on how it's actually, how it's going. There we have also certain levels that we have defined. And the third one focuses on really on evaluation, which is a joint effort. We want to improve, we want to get better. And there's also certain levels that we have defined. I'm not going to explain all the levels because we're in the middle of the process of iterating and reiterating and writing plans, etc. But I wanted to give you a bit of insight on how we try to grasp these two concepts that are existing on certain levels, but also new on others, and how we're trying to actually do this validation and where the questions are coming from. I think that are my slides for, yes, thank you.
Yes, indeed. Any questions so far for Isaac or Martin? Martijn, sorry.
There are no questions in the chat. So if you have a question, please just raise your hand.
Yeah.
Wolf has a question. Could you please?
Yeah, I have to switch on
yes.
my camera.
Yes.
Is there in the TCP development, is there any a space for different groups of road users, like trucks or bicycles, maybe?
Yes, so we talked about this in the project. Within TISGRADE, we agreed to focus upon private motorized traffic. So that will be our main focus. But of course, everything that we will be developing, we want to make it modular enough, let's say, open enough, to add other categories afterwards. But within the TISGRADE project itself, we will focus on private motorized traffic.
Okay. And a second question for Martijn. In the avoid service requests, is there the destination of the different road users? Is that taken into account? So you can do a rerouting request maybe for a certain group of destinations.
We haven't gotten that far with developing what this avoid serve request would look like.
Okay.
That's definitely something that's on our mind. I mean, within the Socrates project, of course, there was the smart destination use case that was done. And we feel that there is some value in how they set things up and how they cooperated with service providers. So there's definitely some value in what is there, but we also need to take into account the lessons they learned there. So we're like in the process of developing what it could be, how we should phrase it, how we should use it, etc. But this is definitely something that we'll try to take into account, but of course we are trying to validate as well within the deployment validation.
It's too early.
Yeah, it's too early. Yes.
Yeah, and it's quite a challenge already. So we have to start somewhere and then indeed build on it. Yeah. Any other questions before we move over to the next topic? And there's also room for discussion afterwards. So no questions, Barbara?
Oh, no. I think it's also good to continue. Yeah.
Then I hand over to Stefan.
Good morning, everyone. My name is Stefan Chobel. I'm representing ETICO, the European ITS Association. I'm also wearing my hat of a coordinator of the TNITS platform on road data exchange between authorities and service providers. So next slide, please. This short introduction will elaborate on the pre-deployment setup report for the maximum speed limit validation. So you will see the new acronym MSL, maximum speed limit validation, for this particular project and process. So we were coordinating the activities to define the setup report for the maximum speed validation. You see on the right-hand side, the report is out. It says you can find it on the TNITS site. The objective of our activities were to establish a validation framework for maximum speed limit validation. The scope was to do the analysis across multiple PDVs. In Europe, we have not all the signs that Annette showed. We have a limited set. I will come back to that on one of the next slides. Our work took place between November last year and April this year. The coordination was done by ETICO. The approach was that we started off with contacting the authorities in our project via a survey. We also did stakeholder engagement one-on-ones with all the involved parties. We started by reviewing all the existing data validation practices across the PDVs. We performed the initial mapping of the data chains, the roles, the responsibilities, and so on. The outcome of that work was the initial baseline validation plan for the PDVs. And we were also able to collect the foundation for gap analysis and the improvements. That's an action that will, or an activity that will result in a document later in the TISGRADE project. Next slide, please. Okay, this is just to mention that the report will also soon be on the TISGRADE site. Next slide. Okay, if we look at the maximum speed limit pre-deployment validation sites, we see they reflect different road types. We have PDVs for urban nodes, like in Amsterdam, Helmond, Göteborg, also in the France Mediterranean area and in Athens. We are looking at urban nodes we are looking at regional roads in France, Slovenia, Cyprus, at interurban roads in France, Spain, Slovenia, and on motorways in France, Spain, Slovenia, and Cyprus. Next slide. This brings me to the description of the validation ecosystem. I will elaborate on the figure in a moment, but one of the core principles we have realized that there is no single source of truth, and we need to reconcile different informations, legal, like traffic regulation orders, existing maximum speed limit digital databases in various representations as signs or as linear or GIS databases describing linear elements carrying speed limit information, and also the physical signage and markings. So we are in a situation where we need to reconcile all these different types of data, and we realize that there is no single source of truth. This brings me to the operational landscape. We use this landscape to map out for each PDV where the organizations are involved in, what data sources they hold, what the core maximum speed limit database is, what are the validation triggers, what are the validation metrics, the validation steps, the publication of the maximum speed limit data, and the use of the access points. So key roles and responsibilities were defined, and you see on the bottom left all the key elements that I just mentioned. Okay, next slide. So based on the surveys and the one-on-ones, we could identify the current state and have the key findings. So the PDVs in general show a high variability in maturity and capabilities on data availability and on data quality. The common issues that were identified that there's a lack of automated validation workflows. There's fragmented governance across the stakeholders. There's missing or weak, or I would say initial feedback loops available. With feedback loop, I mean the feedback loop from a service provider back to a data provider. We also noticed that there were like inconsistencies in the data, and that the availability was incomplete. Also on the technical landscape, we are looking across the PDVs at very mixed environment. We have mixed standards. We have uneven technical maturity across the PDV sites. Next slide. This brings me to the validation framework that we have defined. So this framework for maximum speed limit describes the scope and the boundaries of the validation framework, the roles and responsibilities. It describes 5 validation blocks, and it would be a bit too, I don't have enough time to address all of them, but the first 2 blocks describes all the processes and actions where the validation is done by the data users, mainly by humans, for example, on data entries, checks, comparing data sets, and the actions are triggered by regular action or regular actions, or by new actions like a new survey or a new legal order that was published. The feedback driven, so block B3, feedback driven describes actions if a feedback loop is introduced, and then 4 automation driven. That block describes where all advanced automated processes are deployed, combining geographical rules, road and traffic attributes, mainly restrictions, and some spatial intelligence. And then on block 5, there we are looking at all the processes and the actions that are performed by the data user on published data sets, either on their services, their clouds, or on those on the national access point. So think about performing compliance checks, doing provenance checks, and so on. Okay, then we also include in the validation framework, of course, the quality dimension, accuracy, consistency, and so on. We include the TISA 5-star rating. We have indicated KPIs, although we have not formally established values for the KPIs. That is going to emerge during the actual work, the validation phase. And we also introduced the criteria, so the description of these KPIs. We formulated implementation recommendations, and we also addressed maturity levels for the maximum speed validation. And you see that there are different phases. At the beginning of the project, phase 1 is where a feedback loop becomes operational, and at the end of phase 1, so with the fully mature feedback loop, we will have a re-evaluation of the validation framework. Next slide. Okay, on the validation of the quality of maximum speed limit data and the improvements in availability. So when we look at the 7 PDV sites, we see that there is the initial specific validation plans that were established by the site owners themselves. And we introduced the stepwise phased approach, as you've seen on the previous slide. I also have to mention the contribution of MAP and service providers in the feedback loop. So the feedback loop as a work package in TISGRADE will be addressed in another work package. But here we will rely on the results of an implemented feedback loop. I have to indicate that here and B-Mobile are both service providers that have committed to provide feedback. And some initial discussions have been initiated, and more will follow. So next slide. And I think this is my last slide. This is just to mention that in the report, there are 2 annexes. One is elaborating on the precedent practices, and the result of MAPcore is one of the most important guideline documents for establishing this validation framework. And then in Annex 2, a validation plan per PDV site is described. So that's it for my side. I welcome questions.
Yes, Jessica has a question.
Morning from Amsterdam. I was wondering, do you do the check on the maximum speed limits? Are you planning to have them checked on the national access point level, or per road authority, or per region? How do you envision that in the future? And for now, for the PDV?
Well, okay. on a short term, it's the data user, which is in our definition is the authority, the road authority, the city authority. They are going to perform the initial validation of the maximum speed limit data that they own. And then in the phases I mentioned, the secondary phases where the feedback loop is involved, then it's a coordinated activity between a service provider that is using the data and is feeding back information to the data user. I agree it's a bit confusing, data user, data owner, but in our definition, data user is the authority, and the service provider is the entity that provides the feedback data.
And this is also an element of the working with package 5, because indeed we have to find out, considering all the different circumstances and starting points, what the role of the national access points in this whole process will be. They will probably indeed have a function in this, but since it all differs per country how it is organized, we have to find out indeed what will work in a practical way, because indeed the data owners are the road authority. So yeah. Any other questions for Stefan? Some questions in the chat, Barbara? Oh yeah, I see.
Yes, there's a question in the chat.
Hi,
And-
Stefan. Thank you for the presentation. A quick question, since that we have one of the PDVs in Cyprus, and I have a question related with the static speed limits data. Since that they are points, and you mentioned that the assessment is planned to be done by the TISA 5-star rating, and some of the criteria that we have in the use case of the speed limit from TISA 5-star rating is based on linear reference. So my question is, will this be a problem since that 10 ITS data set should be points and TISA 5-star rating is based on linear reference to achieve specific levels of quality?
Rodolfo, that's a good point and something which is on my mind. Indeed, you are correct. The TISA 5-star rating, especially from level 3 on, stipulates that speed limit data needs to be represented by lines, so polygons, or polylines, I should say. That's true. However, I know that the MOP and service providers like TomTom, Google, here and so on are expert in mapping these point features to linear features of their own database. So I would say, as a starting point, provide the speed limits as point features, like reflecting traffic signs. And in a second phase, see if you are capable of linearizing these point features and then bring that into the data chain. I would advise to follow this approach because this linearization is work for experts, for specialists, and as I mentioned, the service providers I have indicated have a lot of expertise in this process. So maybe the quality would be higher if you leave it up to them to do this linearization, but subject to discussion and maybe some trials.
Thank you, Stephen.
That's also one of the goals of TISGRADE, to start using the TISA 5-star rating in a practical way and see what we encounter and how we can solve it, and work in progress. Yeah. Any other questions for Stefan? In the chat, there was a question, Barbara.
Yeah, there's 2 questions in the chat, but we can also maybe save them for the end.
Yeah, then we hand over to Bart Lano.
Yes, good morning. So I will give you an overview of the last activity for today. It's on dynamic data validation. So I'm Bart Lano from B-Mobile. We are one of the service providers in the project. We are based in Belgium, but we have activities over several European countries. So next slide. So it's a similar slide as the first one from Stefan, but now it's really focusing on the roadworks, road and lane closure validation. Objective is quite similar. It's establishing a consistent, measurable and scalable validation framework, but focused on these 3 use cases. We did it as well, or we will do it as well in different pre-deployment validation sites. Most of them are involved here. We have, I think in total there are 16 or 17 in the project, and we are active in 15 of them, spread over 10 different countries. Approach quite similar like the one that was presented by Stefan. So we started with service and stakeholder engagement. So a lot of one-on-one meetings together with all the PDV sites to see, okay, what's the current status, what are the tools available, and so on. So it was really a review of this existing data validation practices. And we did some initial mapping then also to see, okay, what are the different roles there in a PDV, who is responsible for what, and so on. And that is then the start for this, the initial baseline for the validation plan. That was also the base of the report that was published then a few months ago. So it's also, I think, accessible through the website. And that's then the start for our next phase that will end somewhere, I think Q2, Q3 2027, where we have this foundation with the gap analysis and the improvements in this the next deliverable. You see here there are two deliverables combined. Originally in the proposal, we split the roadworks and then also as one, and road and lane closures as a second topic. But because there are a lot of similarities, we in the end decided to take this together and really focus, have it in one document, have a common approach, and so on. Next slide. Yeah, and the document can be found there. So where do we stand? Yeah, I don't have an overview of the exact PDVs, but as I said, most of them are involved here. And we see, yeah, generally speaking, a lot of fragmented, also a lot of manual validation approaches across the countries, across the PDVs. Also inconsistent data quality, unfortunately, with gaps in completeness, timeliness, and accuracy. But of course, that's not for all the PDVs the same. So we also saw a lot of difference in maturity. But the consequence is that there is from the service providers sometimes limited trust in the data published by the road authorities. On the other way around, if it's not used too much, there is also less incentive for the road authorities to improve data. So we are in a kind of chicken and egg position, and that's also one of the goals to make this better because of TISGRADE. Regarding the coverage, so we see on this data, there is a good coverage typically on major roads. They are also under responsibility of the national road authorities, while there are more gaps on secondary roads. Also about smaller road works it's sometimes not that easy. So for example, 1 or 2 days road works just to do some works on electricity or some other utility is less available than a really bigger road work. DATEX2 is widely adapted and data is published via the national access points, of course, when it's available. The more mature PDVs, there we see real-time data. While, yeah, this is not the case for all of them. And the validation is very often still manual, and there are limited automation or feedback loops, especially for then quality validation. So as already said, there is a kind of large maturity range. Yeah, you can go to the next one where I'll give some examples about best. I know first this one, TISGRADE approach. Sorry. As already mentioned in the previous talk from Stefan, TISA 5-star framework is also one of the bases here. Why TISA 5-star? Well, we were really looking for a common validation methodology. And in overview, this is one of the better ones that are existing. Is everything already in stone settled? No. TISGRADE is also meant to just evaluate this validation methodology to do upgrades and so on. But it's important to have a common language and to be very harmonized so that we can compare these PDVs in an equal way. Within the approach, so we start with the historical data collection to have a baseline. Desk analysis is done really on the data feeds to see if it's for the completeness and the usage standard and so on. But then what's really important to bring this to the next level is to do some final validation based on the data compared with the real world and grown through data. And that's also something to really put focus on and to see how far can we go there, and is automation possible, and what will it cost, and so on. And in the end, this 5-star rating is also used in for the quality improvement, so that we have an aggregated way of presenting it and can easily compare between countries, as already said. Next slide. A few best practices that I want to share with you. For example, in the Netherlands, they use the Melvin tool, which is a platform, which is a national coordination platform for roadworks and crowd-generated events. So in the end, it's kind of planning tool. It also makes sure that closures are not conflicting each other, interfaces with other tools are set up. And in the end, this data should go further shared with service providers. And by doing this coordination at the source level, it also prevents downstream quality failures. So also, yeah, it's a tool which is very relevant to have a good overview of all what's happening on the road, and it's used by the national road operator, but also by the municipalities, the provinces, and so on, to have a complete picture. At least that is the goal. Yeah, it's then mainly a matter of the people inserting the data. So in Melvin, typically you have still this manual intervention. Then another example is the connected cones, which are used today in Spain. These are more IoT like devices, so that you put in on street when a roadwork is starting, with an immediate activation or deactivation when it ends, and it gives then an exact location. It can give exact timing. So it's really meant for automated generation of where is the roadworks happening. But of course, you're still dependent on the road worker that has to activate or deactivate. So in Spain, they have a kind of resolution from DGT that is now, I think, obliged, or at least very well recommended from January last year. Next one. So the first was on data input. Next is data enrichment. One example here used amongst others by the city of Amsterdam, where they do roadwork validation with floating car data. So what you see in the picture, so there are some planned dates for the roadworks, first and second day here. But if you then compare it to floating car data, we see on day one, traffic is flowing still there, like in a typical Monday. So it means most probably that the roadworks are not started yet. The other way, on the Wednesday, you see the reality is a real difference. There is still no traffic, so roadworks are still there. And then on Thursday, the fourth day, there is some, yeah, you see there is some traffic delay compared to the historical pattern. So maybe one lane is still closed, another is open. So it's coming up, it's starting again the traffic, but it's not there yet. So it gives really key insights where roadworks are executed. If you compare a database where you already have an indication when it should happen, and you compare it with floating car data. Next one. On data validation, it's also a topic that we at B-Mobile are working on. So we have a data platform called B-Warrant. It's used both for RTTI and SRTI data. Of course, in TISGRADE, all the use cases are RTTI, so real-time traffic information. And we use our tooling, so the data sources, a lot of data sources can be combined, and then we do the validation between them. And it's a kind of then merge and decide what is the best data source and to further increase the level of the data quality. Also there we do validation, or at least is the goal within TISGRADE, and then to further see can it be further exploited, initially based on the 5-star rating. Most important is that we have a common validation methodology to see how the data is. What we also see, it sometimes have the perfect data is very hard. So it's already good to start with good enough data and to further continuously improve by adding different sources to the platform and to increase your quality. Next one. So some key gaps identified. I also have to keep an eye on the time, so I will not go in all detail here. But what we see, a lot is already mentioned. So a lot of manual processing still. We see limited use of this floating car data and feedback loops, and so little automation. There are sometimes completeness and timeliness gaps. Standards sometimes still fragmented, although a lot of DataX2 is already used, but some are even not digitalized yet. And the feedback loop, already mentioned, it's also a part of TISGRADE in the work package 5. It's still absent a lot, but we will work on it. Next. Yeah, and that's my final slide. More or less a summary. Yeah, and I think I will just stop here because we only have 4 minutes left.
Yeah, thank you very much. And we have some minutes left indeed for questions. And there were two in the chat. Barbara?
Yeah, Esther, would you like to ask your question via the microphone?
Yes, it's more like Stefan, you explained a little bit the 5-star rating as a base, and how do you make sure that the roadside signs, the maximum speeds, are aligned with the ones that are indicated in the navigation systems? What kind of tools are you using to align this? Can you give some examples of the different PDVs?
Right. So on tools, what you see is that there is a consensus, I would say, among the different PDVs to start from either legal sources or from observations of road data, for example, with this type of mobile mapping devices. So collecting street level imagery is probably the starting point. So there's definitely tools that are necessary to do that. The extraction of traffic signs and all speed related information could also be the paintings on the road surface. Their AI tools have emerged over the last decade, I should say. So there's also a suite of tools for the extraction of speed limit data on mobile mapping data. And then the third part is I would say the GIS tools that are available at human operators to explore any issues that AI might have come up with. So they can do checks, they can handle issues. So those three categories of tools: data collection, data processing, and then data inspection, I would say, by humans. Those are the three categories of tools that are in place by most of the PDVs.
Thank you.
Louis had a question, but he had to leave, and we speak him on a regular basis, so that will solve itself. Are there any other questions? We have 1 more minute left, so. And we do have a question for you, because this was our first TISGRADE talk. I said in the beginning to inform you about the work we are doing, because it's relevant also for not TISGRADE partners. So we would really like to receive your feedback on this TISGRADE talk. Was it too detailed or not detailed enough? We are organizing a next one. And well, I will share my final slide after the summer. And if you want to stay involved in the project, we have the website, thanks to Esther, now available, TISGRADE.eu. There you can find more information about the project. We also have a dedicated LinkedIn page. If you want to subscribe to the newsletter, you can do so via the website. We also have within TISGRADE a public-private tactical group, which is open for non-TISGRADE partners, and the next one will be in autumn, probably on 16 and 17 September, but we still have to finalize that. So these are the ways that you can stay involved if you are not already involved. And yeah, looking forward to your feedback on the TISGRADE talk, because the goal is to inform you all. I see a hand from Benjamin. Go ahead.
Hello, just one question. Where can I find the presentations, and how can I get into this tactical group? Is there a kind of registration out there?
For the tactical group?
Mm.
Yeah, please send me an email and I make sure you get invited.
Okay, thank you.
Yeah.
And the presentation from today, where can I find them?
We will share the presentation on the website.
Yeah.
Great.
This
Okay,
grade.
perfect.
Yeah. Just as the
Thank you.
recording of this webinar. Yeah.
Yeah.
Great, thank you.
Well, thank you all for your attendance, and have a good day. Hopefully not too warm.
Thank
Bye-bye.
you. You too. Bye.
Bye.
Bye-bye.
Thank
Thank
you.
you.
Thanks. Super useful.